Hello students, today we are going to learn about what is gas chromatography, which we know as GC, and what are the components of GC. So GC or gas chromatography is a separation technique used to separate individual components of a volatile molecule. So what are volatile molecules? Volatile molecules are those molecules which gets evaporated easily at room temperature. The stationary phase is either a solid or liquid in GC, while the mobile phase is in gaseous state. Based on the stationary phase, we have two types of GC, and they are gas solid chromatography and gas liquid chromatography. In gas solid chromatography, gas is the mobile phase and the solid is the stationary phase. While in gas liquid chromatography, the gas is the mobile phase and the liquid is the stationary phase. The theory of GC is based on partition principle. The sample is first converted into vapor and mixed with a gaseous mobile phase. Separation is done based on distribution coefficient. The molecule whose interaction is more with the mobile phase will get separated earlier, and the molecule whose affinity or attraction is stronger with the stationary phase will get separated later. Now coming to the components of GC, the first component of GC is the column. This is the column. And the column used in GC is arranged in coil. The coil in GC are basically of two types, packed column and capillary column. The coil is placed inside a chamber to maintain a uniform temperature. Packed column is made up of stainless steel or glass. Its length is about 1 to 3 meters and its inner diameter is about 2 to 4 millimeter. Capillary column is made up of fused quartz. Its length is about 10 to 100 meters and its inner diameter is 0.1 to 1 millimeter. The second component is the stationary phase. It is placed in the inner wall of the column. The stationary phase is made up of silicone grease or wax to withstand high temperature. This is the column, and in the inner wall of the column, the stationary phase is placed. The third component is the mobile phase. Mobile phase is in gaseous state and it may be helium or nitrogen. The mobile phase is basically a carrier gas, and the carrier gas are helium, nitrogen, argon or hydrogen. These are the carrier gases. The fourth component is the cylinder. The cylinder contains the mobile phase inside it. Cylinder is attached to the molecular sieve. The molecular sieve removes unwanted hydrocarbons, water vapor or oxygen which may interfere with the sample during analysis. The fifth component is the detector. In the end, the detector detects the sample. For example, a FID detector, that is a flame ionization detector. Flame I will make a separate video on the types of detector. Coming to the working principle of GC, the sample which needs to be separated is mixed with a volatile solvent like heptane, acetone or methanol. This is the cylinder which contains the mobile phase. It is connected to a molecular sieve which separates or removes the hydrocarbons, water vapor, oxygen which may interfere with the sample during the analysis. This is the septum in which the sample is injected. The temperature of the injection region is kept 20 degrees centigrade to 50 degrees centigrade higher than the column, which allows rapid volatilization of the sample. The volatilized sample passes down the column and separation occurs. The separated molecules are then detected by the detector and the graph is produced or formed in the screen.